Now let's write the Java code for finding the insert position of a particular value in a sorted array of values that we have been given using the binary search algorithm that we have discussed previously, right? Let's write the Java code for that. Here, first of all, let me just define start and initialize it with 0, and similarly, let me just define another variable end. This, let me just initialize it with the last index that we have on the array. Similarly, here I'm going to define one variable mid and I'm initializing it with -1. Now I will simply run a loop as long as the start is less than or equal to end. What I will do is, similarly, however we were calculating the middle, right? We will simply calculate the middle. Middle is nothing but start plus end divided by 2. Once we calculate the middle, as part of the problem statement that we have got, if at all this target is found inside this array, we will simply return that index itself. That's the reason why here, first of all, what we will do is, if at all the value we have at this middle is equal to the target we have been given, in that case, the middle index is having the value the target, whatever the target value we have been given, hence we will simply return middle itself. Otherwise, our aim is to move the start value, whatever we have, to the actual insert position. So here, obviously the other scenarios are basically greater than less than, right? If at all the value we have at this middle is greater than whatever the value we have got inside the target, then what we need to do, we need to search in the left part of the array, because the value we have at the middle is greater than the target we have given. So it can go anywhere on the left part of the array. To continue the search on the left part of the array, we will simply update end with middle -1. Obviously the other case is, whatever the value we have in the middle is less than target value, right? It could be inserted anywhere on the right side. So to continue the search on the right side, what we will do, simply we will update the start with middle +1. Once we complete this while loop, right, whatever the value we have inside this start variable will be the index at which we can insert this target value. So here we will simply return whatever the value we have in the start. It's as simple as that. No modifications, nothing. We have already solved a lot of problems in the similar fashion. It's just that here, whatever the value we have inside the start index will basically represent the position at which this target value can be inserted in the sorted array of values we have been given. Okay, so that is all about. Anyway, here I have given one sorted array which is sorted in the ascending order, and target is 5. So I want to insert 5 in the appropriate position inside this array such that it can be sorted in the end also. I mean after inserting 5 again. So I have created the object of that class and I have called that function passed array and target. Now if I run this now, run as Java application. Okay, you see the output that we have got is 4. Okay, 4 is basically 0, 1, 2, 3, 4. So we can insert the value of 5 at index 4 such that the array will still remain sorted. For example, let's just say here we don't have 5. We have 4, 6, 7. Okay, and let's just assume 4 is also not there. The input array is basically 1, 2, 3, 6, 7. So the value of 5 can go at index 0, 1, 2, 3, right? So the output should be 3. Run as Java application. See, the output that we have got is 3. Okay. Similarly, let's just say the array that I'm passing is empty. In this case, obviously, whatever the value we have in the target is 5. So it can go at index 0. So if I run the application now, the output is 0. Okay, since the array is empty, 5 can be inserted at index 0 such that the array will remain sorted. So that is how we implement the solution for finding the insert position in a sorted array for a given target value using binary searching algorithm. Okay, so that's it for this one. I'll see you in the next problem.